Hello again, this is Rodolfo Eric Angat, your teacher in Earth and Environmental Science. Today we'll be discovering about Kepler's law. So what is Kepler's law? Kepler's law talks about planetary motion. Remember that planets exhibit motion. Kepler's law explained this to us, and it explains it to us in three laws. So there are three Kepler's law. Kepler's first law states that planets' orbits are elliptical. So what we know about this is that the orbits of the planets like Earth, Jupiter, Saturn, Mercury, Venus, Earth, Mars, they all have an elliptical orbit. Of course, the degree of how elliptical they are vary, but they all have elliptical orbits. That's Kepler's first law. Remember, the key word is elliptical or ellipse. Kepler's second law states that planets sweep out equal areas in equal times. We'll be learning more about this when I show you the picture of Kepler's second law. But I need you to remember this concept for now. The third law is the combination of the first and the second law. The third law shows the relationship between the distance of planets from the sun and their orbital periods. Orbital period simply tells us how fast the planet is when it orbits around the barycenter of the solar system or around the sun. Now, let's look at the pictures. This is Kepler's first law. I need you to remember how it looks like and its concept. It might vary in different representations, but basically Kepler's first law simply shows us that the orbit of any planet is elliptical. It is not circular. It is elliptical, just like this one. Okay? Now, this is the sun, and this planet can be Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus. Okay? And the orbit is elliptical, but the level of eccentricity is not always the same. Some are more elliptical than others. Again, Kepler's first law states that the orbit is elliptical. The second law, or Kepler's second law, moves a little bit higher. It not only shows us that the orbit is elliptical, it also shows us the planet in different places in their orbit and the areas that they covered between them and the star or between them and the sun. But before we discuss more about that, let's learn more about aphelion. Aphelion is the point in the planet's orbit where it is farthest from the sun. On the other hand, perihelion is the point of the planet's orbit when it is closest to the sun. Now, one thing that you have to remember about aphelion and perihelion is that during aphelion, when the Earth is farthest from the sun, it's actually summer in the United States. Okay? And when Earth is in the perihelion or when it is closest to the sun, it is winter in the United States. That might be illogical, right? Because when Earth is farthest away from the sun, it should be colder, it should be winter, but it's not. It's actually summer. Okay? And here, it's it's very close to the sun. It should be summer, but it's not. It's winter. Okay, so it's very illogical if you come to think about it, but then it's not. You have to remember that the reason why we have seasons is not the distance between the earth and the sun, but because earth is tilted on its axis. The reason why we have seasons is because earth is tilted at 23.5 degrees plus and minus some degrees. Now, again, when Earth is farthest from the sun, it's summer. And when Earth is closest to the sun, it's winter here in the United States. I'm not saying in the whole world, okay? Just here in the United States. Remember, the season in the Southern Hemisphere are opposite to the seasons in the Northern Hemisphere. But we'll be learning about that when we learn about seasons, climates, and weather, something like that. Now, let's go back to Kepler's second law. Now, let's say that Earth traveled from this point to that point in 5 days. So as you can see, it only covered a little bit of orbit, just this much, because it's very far from the sun. But when it is in perihelion, in 5 days, same amount of time, it covered this much orbit. Okay, so equal time. 5 days, 5 days. So that goes with the equal times. How about equal areas? If you shade the part that was covered between the Earth and the Sun and the orbit that it covered, of course, you will know that this shaded part here is equal in area to the shaded part here. Okay, so just kind of remember this one. When you buy a pizza and then you bake it at home and then you slice it, sometimes you see two slices that seems not of the same size, but when you really compare them, they're just the same. It's just that their shape are not the same, but the amount is just the same. Of course, most of the time, some are really bigger than the others. But let me just give you another example. When you go to a store, you find different kinds of bottles. Some bottles are deceiving. You might think that they have more, but they only actually have the same amount as the other bottles. So the best thing that you can do is to look at the label and see how many fluoride ounces or how many milliliters they contain, so that you would really know they are how much is one more than the others, or they are just simply equal. So the shapes can be deceiving when it comes to the sizes and to the areas. Okay, this shape, this shaded part here is equal to the shaded part here. Equal area, equal times. That's Kepler's second law. Again, during aphelion, Earth only covered a little bit of orbit because it's farthest away from the sun, while here, Earth covered a lot of orbit because it's closer to the sun. It's all about the gravity. So equal time, 5 days, and equal areas. So remember this picture. If you see shaded parts like this, remember that is second law. And the third law is a mathematical formula, but in this class, we will not be really discussing this, but definitely when you take AP Environmental Science or AP Earth Science or any other higher level science, you'll be learning more about this one. Okay, so that's it. We will be seeing each other during our class discussion. And if you have any question, ask. See you.